All right, let's talk about something wild that just came out of Google DeepMind. They've just released a new AI system called Alpha Evolve, and this is no exaggeration. It's actually evolving algorithms on its own. We're not just talking about an AI that generates code like your typical large language model. No, this one invents entirely new algorithms that outperform human-written ones. And it's already saving Google millions in computing resources. Yeah, this one's a big deal. So here's what's happening. Alpha Evolve combines Gemini's language models with an evolutionary system. It uses the creative strengths of LLMs to propose new solutions, then runs those solutions through to automated evaluators. The weak ones get tossed. The promising ones? Refined. This loop keeps running until the best possible algorithm emerges. Think, survival of the fittest, but for code. And here's the kicker. Google isn't just testing this in a lab. They've already been running Alpha Evolve live across their infrastructure for over a year. It's embedded in systems like Borg, Google's massive data center scheduling platform, and just one of Alpha Evolve's algorithms helped recover 0.7% of their global compute resources. That might sound small, but at Google's scale, that's millions of dollars in efficiency gains. Now, what makes this even crazier is how Alpha Evolve tackles problems. Most traditional AI tools write short code snippets or patch small functions. But Alpha Evolve, it's evolving full programs, hundreds of lines of code, with deep, complex logic. We're way past autocomplete. This thing is designing infrastructure. One of the biggest highlights? It optimized a key kernel used in training Gemini models, specifically a matrix multiplication operation. That one change alone led to a 23% speed up in that operation and reduced overall training time by 1%. And sure, 1% might not sound revolutionary, but when you're training models across massive clusters for days or weeks, that's a game changer. It saves time, money, and energy. It didn't stop there. Alpha Evolve also discovered a better configuration for an arithmetic circuit used in Google's custom tensor processing units, TPUs. It removed some unnecessary components from a highly optimized design. The proposed changes? Passed verification, approved by engineers, now part of an upcoming TPU design. And get this, it did it in Verilog, the actual hardware design language chip engineers use. So yeah, we're in a new era. AI and human engineers are now collaborating at the same technical level, and it's not just about performance. Alpha Evolve's code isn't some messy, unreadable spaghetti. The algorithms it discovers are clean, interpretable, and easy to debug or deploy. That makes it way easier for real-world engineers to use the results without spending weeks decoding AI output. But here's where things get really nuts. Alpha Evolve just broke a mathematical record that had stood for over 50 years. Back in 1969, mathematician Volker Strassen created an algorithm to multiply two 4x4 matrices using 49 scalar multiplications. And nobody had beaten that record. Until now. Alpha Evolve did it in 48. That's the first time Strassen's record has been broken for complex valued 4x4 matrices. A mathematical wall that stood for half a century, shattered by a Gemini-powered AI coding agent. This isn't just about breaking records for fun. Matrix multiplication is everywhere, from graphics to machine learning, and it's done trillions of times a day. Even a tiny improvement ripples across massive systems. Now, to be fair, Alpha Evolve didn't get this in one shot. For that matrix problem, it generated and tested over 16,000 algorithm candidates. That's the beauty of it. It's not guessing randomly, it's applying evolutionary logic, trying, testing, tweaking, repeating. over and over until the best solution comes out. Sound familiar? If it reminds you of Alpha Tensor or AlphaDev, it should. Those were DeepMind's earlier projects optimizing basic computations. Alpha Tensor tackled matrix multiplication too, but only with binary inputs. AlphaDev worked on sorting and hashing operations. Alpha Evolve, it goes further. It generalizes the whole process. If a problem can be expressed in code and evaluated automatically, Alpha Evolve can tackle it. DeepMind tested it on over 50 different math problems, from number theory to geometry to Fourier analysis. And it matched the best human-made solutions 75% of the time. In around 20% of cases, it improved on them. That includes the kissing number problem, an ancient geometry challenge dating back to Newton. The goal: how many spheres can touch another in 11 dimensions? The old record was 592. Alpha Evolve found 593. One more sphere might not sound like much, but mathematically, it's a huge leap. Let's break down how Alpha Evolve actually works under the hood. It's built on two versions of Google's Gemini model, Gemini Flash and Gemini Pro. Flash is fast, lightweight, rapid-fire idea generation. It can crank out thousands of snippets in minutes. That's your first wave of ideas. Gemini Pro? Slower, deeper, more powerful. It's for the complex logic and deep reasoning. Here's the flow. The system starts with a prompt, a problem description, past attempts, or target outcomes. Flash generates thousands of candidate solutions. Each one is scored by automated evaluators. No human feedback needed. Does it work? Is it faster? Is it more efficient? The top candidates, say the top 1%, become parents for the next round. This evolution loop continues generation after generation. If things stagnate, Alpha Evolve throws in an old candidate to shake things up. If Flash is out of ideas, Pro steps in, bringing totally new strategies. And this can go on for hundreds of iterations because the feedback is instant. Metrics like speed, memory, energy. Alpha Evolve keeps moving at full speed. What would take engineers weeks now happens in days. And unlike a human team, Alpha Evolve never sleeps, never loses focus, and explores paths no human might even consider. That's why it's not just writing code. It's discovering algorithms, outperforming decades-old human solutions, one evolutionary loop at a time. Now, this only works when solutions can be scored automatically. That's one limitation. It can't be used for tasks requiring subjective judgment, like writing poetry or analyzing lab results. Also, while Alpha Evolve produces results, it doesn't always explain why a solution works. So the theoretical insights, still up to us. But the practical results? Unstoppable. Instead of handcrafting code, we now have AI collaborators capable of relentless, creative exploration. And here's the most exciting part. As language models evolve, Alpha Evolve gets stronger. Right now, it's reshaping infrastructure, chip design, and AI model training. But Google plans to expand it into materials science, sustainability, and even drug discovery. Anywhere that involves measurable, algorithmic complexity. DeepMind is already working on a user interface with their People plus AI research team and launching early access for academic researchers. So yeah, if this is where AI coding agents are in mid-2025, the next couple of years are going to be very interesting. So now the big question. What happens when the smartest algorithms on the planet are no longer written by humans, but by machines evolving in silence? If you found this as mind-blowing as I did, make sure to like the video, subscribe, and let me know your thoughts in the comments. Thanks for watching, and I'll see you in the next one.